Good afternoon, students. Welcome back once again to the mathematics class. In today's lecture, we are going to study some problems based on homogeneous differential equation. Right? Examples on homogeneous differential equations. Right? In yesterday's class, we have seen how to solve a differential equation, that is homogeneous differential equation, by using the variable separable and initially by finding its homogeneity. Right? Whether it is homogeneous or not, initially we have to find out it's homogeneous or not. Later on, by using variable separable method, we solve the differential equation as homogeneous differential equation. So let us consider example. First example, example 1. Solve the differential equation y dash, which is equals to x plus y upon x. Right? So solution. Let us consider we have dy by dx, which is equals to x plus y upon x. Right? This is homogeneous differential equation of degree 1, we can say, because its power is 1, its power is 1, its power is also 1, right? So a numerator as well as denominator have a same degree, then we can say it is a homogeneous, right? So this is a homogeneous differential equation of degree 1, right? So now take it as equation 1, this equation. Put y equals to v of x, which implies dy by dx, which is equals to, we are going to give formula v plus of x dv by dx, right? So putting the value of y and dy, putting the values of y and dy by dx in 1, we get, in equation 1 we have to substitute. Let's see what we get. V plus x dv by dx in the LHS, which is equals to x plus Vx. Y means here Vx upon x as it is. So by taking x common here, what we get? V plus of x dv by dx, which is equals to, by taking x inside, 1 plus v upon x get cancel, remaining right down as it is, v plus of x dv by dx, which is equals to 1 plus of v, right? So now take plus v to the RHS. It is x dv by dx, which is equals to 1 plus of v minus v. And this v to RHS. So plus v minus v get cancelled. X dv by dx, which is equals to 1. So now separating the variables. Separating the variables v and x, right? Then we have dv equals to dx upon x, right? So now integrate. After variable separable, integrate, we get the integration of dv is v, and integration of dx upon x, which is equals to v log x plus of log c, which is equals to v log m into n can be written as log mn, right? Take it as equation 2. On putting the value of v in equation 2, on putting the value of v in 2, then we get, yes, which is equals to what? V equals to y by x, which is equals to log cx. Therefore y keep here only, x log cx is nothing but our required answer of this given differential equation, right? Got it? Initially just find out whether it is homogeneous or not. Later on, as usual, variable separable method, separate the variables and integrate it, and finally substitute the value of v in the given equation. So finally we get the solution of that differential equation. Similarly, next example, it is example 2. Solve the differential equation. Solve the differential equation x square minus y square dx plus 2xy dy equals to 0, given that y equals to 1 when x equals to 1, right? Let's see the solution of this one. Here a differential equation has been given, that is x square minus y square into dx plus 2xy dy, which is equals to 0, and given the values when y equals to 1 when x equals to 1. So it has been asked in CBSE 2008 also. CBSE 2008, right? So now let us consider, we have x square minus y square dx plus 2xy dy, which is equals to 0, now which can be converted into standard form. It is dy by dx, which is equals to y square minus of x square upon 2xy, right? Just we have converted it by multiplying minus sign. X square minus y square becomes y square minus of x square. Take it as equation 1. Here this is a homogeneous differential equation. This is homogeneous differential equation, right? Because the numerator 2 is there, 2 in the denominator also 2. Therefore the numerator as well as denominator, the order is same, so the degree is same. So this is a homogeneous differential equation, right? So putting y equals to vx and dy by dx, which is equals to v plus of x dv by dx in 1, we get, just substitute the values in equation 1. Let's see, v plus of x dv by dx, which is equals to v square x square minus of x square upon 2x vx, right? So which is equals to what? By taking x square common from the numerator and denominator, we get v square minus 1 upon 2v, right? So again, which implies x dv by dx, which is equals to v square minus 1 upon 2v minus of v, right? So now cross multiply, what we get, which is equals to v square minus 1 minus of 2v square upon 2v. So minus 2v square plus v square, which can be written as x dv by dx. V square minus 1 minus 2v square can be written as here minus v square minus 1 upon 2v again, which is equals to minus taking common outside 1 plus v square upon 2v, right? So now separating the variable, separating the variables v and x, we get, after separating the variable, what we get, let's see, 2v upon 1 plus v square into dv plus of dx upon x, which is equals to 0. Just interchanging the values here, minus dx upon x can be taken as plus dx upon x to the LHS only, right? So now integrating we get log of, it is 2v, sorry, 2v upon 1 plus v square is there, so it becomes log 1 plus v square after integrating, or first apply integration here only, so it becomes log 1 plus v square plus of log x, which is equals to log c, right? So log m plus n can be written as log mn, it is log of 1 plus v square into x, which is equals to log c. Therefore log get cancel, 1 plus v square into x, which is equals to c, right? So finally replacing v by y by x, replacing, take it as equation 2, replacing v by y by x in 2, we obtain 1 plus of y square upon x square into x, which is equals to c. Now cross multiply this, what we get here, x square plus y square upon x square into x, which is equals to c. Here x get cancelled, so the final value is x square plus y square, which is equals to, take this term to that RHS, so it becomes cx. This is nothing but our required solution, that is x square plus y square, which is equals to cx, right? So similarly, next example, It is example 3. Third example. Solve the differential equation. Solve the differential equation x square plus xy into dy, which is equals to x square plus y square into dx, right? So now solution. Let us we have x square plus xy dy, which is equals to x square plus y square into dx, right? So now convert it in the standard form. Now it is dy by dx, which is equals to x square upon x square plus y square upon x square plus xy, right? Take it as equation 1. So this is homogeneous differential equation, we can say, because in the numerator 2, 2, 2, 2, the order is same. If we take by substituting lambda x and lambda y in terms of x and y, again by taking lambda square outside, again you will get second order homogeneous differential equation, right? Therefore it is a homogeneous differential equation. Therefore this is a homogeneous differential equation, right? So now put y equals to vx, so that dy by dx, which is equals to v plus of x dv by dx, in equation 1 we get, just substitute in equation 1, let's see what we get. In LHS, v plus of x dv by dx, which is equals to x square plus v square x square upon x square plus x into vx, which is equals to what we get by taking x square common from numerator and denominator. Here the numerator x square taking common means 1 plus v square. In the denominator also x square common means 1 plus of v. Here x square get cancelled. Finally what we get, 1 plus v square upon 1 plus of v. Therefore again take x dv by dx, this plus v take on RHS, it becomes 1 plus v square upon 1 plus v minus of v, right? So again, which is equals to, after cross multiply, what we get, 1 plus v square minus of v is there already, next 1 plus v, it becomes 1 plus v, so which is equals to 1 plus of v square minus v, plus into minus minus v square, plus v square minus v square get cancelled, so remaining term is 1 minus of v, 1 plus of v, which is equals to, right, it is equals to x dv by dx. So now separating the variables, separating the variables, separating the variables v and x, we get, it is 1 plus v upon 1 minus of v dv LHS, the RHS it becomes dx upon x. Now integrating, we get integration of 1 plus v upon 1 minus v dv which is equals to dx upon x, right? So now in the first term in LHS we are converting this term in terms of, which implies minus 1 plus 2 upon 1 minus v. Can we write like this into dv? Let's cross check once again. 1 minus v, if you multiply into minus 1, it becomes what? Minus 1 plus v, right? Minus 1 plus 2 becomes plus 1. 1 plus v upon 1 minus v as it is. So we have converted it in the form of minus 1 plus upon 2 upon 1 minus v into dv, which is equals to what? Integration of x is log x. So now integrating this, what we get here? Minus v plus of 2 log of 1 minus v, which is equals to log x. So again, which can be written as, this term take on LHS, it becomes log x minus 2 log of 1 minus v plus of v, which is equals to constant c, right? So here substitute the value of, that is equation 2. Put the value of v into v in equation 2. Then we have log x minus, if 2 take on numerator, it becomes log of 1 minus v, just substituting the value of v equals to y by x, right? Just substitute the value, so it becomes log of, to keep as it is here, only one more step we will take here, minus 2 log of 1 minus y by x plus y by x, which is equals to c. So again, what we can do here, log of x minus log of 2, take in the numerator, it becomes x minus y upon, cross multiply this, its whole square plus y by x, which is equals to c. This is nothing but our required equation, right? Log x minus log of x minus y by x whole square plus y by x, right? So next example, we will move to the next one. It is example number 4. Example number 4. Solve the differential equation x square dy by dx, which is equals to x square minus 2y square plus xy, right? The solution. So here, convert the standard form. First, we have x square dy by dx, which is equals to x square minus 2y square plus xy. So now converting this term, which implies in the standard form, it becomes dy by dx, which is equals to x square minus 2y square plus of xy divided by what? X square, take it as equation 1. This is homogeneous equation, we can say. right? Because 2, 2, 2, 2. The numerator is 2, the denominator is also degree 2, therefore it is homogeneous differential equation. This is homogeneous differential equation, right? So now putting y equals to vx and dy by dx, which is equals to v plus of x dv by dx in equation 1, we get, just substitute the value here in equation 1. So we get v plus x dv by dx, which is equals to x square minus 2v square x square plus of x into vx whole divided by x square, right? So again here by taking x square common, which is equals to, inside what we get, 1 minus 2v square plus of v, right? The denominator x square. This get cancel, only what we get, 1 minus 2v square upon plus v, 1 minus 2v square plus v. So which implies x dv upon dx, which is equals to 1 minus 2v square plus of v minus v plus v minus v get cancelled, which is equals to 1 minus 2v square. Now separating the variables, we get dv upon 1 minus 2v square, which is equals to dx upon x, integrating we get, it is what we have to do here, just multiplying and dividing by 2, right? Let's see, which implies in the first LHS term 1 by 2 outside, inside it is dv upon the numerator 2 we are taking, in the denominator that is 1 by 2 minus of v square, right? Multiplying and dividing by, here 2 get cancelled, in the second term that is in v square, multiplying and dividing by 1 by 2 in the numerator as it is, in the denominator 1 by 2 is there. If you multiply inside, what we get, 1 by 2 into 1 is 1 by 2, again 1 by 2 multiply inside means it becomes 2 get cancelled, so 1 by 2 minus v square, which is equals to what, log x plus of, okay, that is constant, so 1 by 2 as it is here, which implies dv, this term can be written as in the denominator 1 by root 2 whole square minus of v square. Can we write like this? Just we are taking root and its square, right? So in the numerator 1 square is again 1, the denominator square root get cancelled means it becomes 1 by 2. So now it is in the standard form, right? It is in the standard form, that is nothing but dx upon a square minus x square, right? So now which is equals to 1 by 2 as it is, now which can be written as 1 upon 2a, it is 2 into a means 1 by root 2 log of a plus x, a minus x is there, that is 1 by root 2 plus v, 1 by root 2 minus v, which is equals to log x plus k. Because I will write here the formula, integration of dx upon a square minus x square, which is equals to 1 upon 2a log of a plus x upon a minus x, right? In a similar manner, we have substituted this in the form of a square minus x square is nothing but 1 by 2a into log of a plus x. Here a means 1 by root 2, x means v is there, right? So after simplification, what we get here, let's see, which is equals to log of 1 by root 2 plus v upon 1 by root 2 minus v, which is equals to, here 2 by 2 root 2 is there. So after simplifying, multiplying and dividing by 2, what we get here, root 2, it becomes 2 root 2. I will write here 1 upon 2 root 2 is there. If we just multiply by root 2, what we get, root 2 upon root 2 whole square, what it becomes, 2 by 2 root 2 is the right, simply. So 2 as it is, square root get cancelled, what we get here, only 2 we get. So similarly 1 upon or 2 by 2 root 2 is there, 2 by 2 root 2 is there, here multiply by root 2 divided by root 2. So what we get here, 2 root 2 upon 2, 2 to get cancelled, only root 2, right? So here also already 2 is there, what we get here, root 2. So 2 root 2 take to the RHS, it becomes 2 root 2 log x plus constant k. Therefore, again, which can be written as log of 1 plus root 2v, cross multiply this, 1 minus root 2v, the denominator root 2 is there, right? So again, which is equals to log x to the power 2 root 2 plus of log c, we are taking this term k. So let 2 root 2 k, just we multiply inside, it is log is there, by applying logarithm property we get log x to the power of 2 root 2, here k can be taken as log c, where 2 root 2 k can be written as log c, right? So now 1 plus root 2v, 1 minus root 2v, denominator here get cancelled in the both the numerator as well as denominator by cross multiplying. So what we get here, log mn, which can be written as c into x to the power of 2 root 2, take it as equation 2, right? So now putting the value of v into, putting the value of v in equation 2, that is nothing but v equals to y by x, right? So here both the log term get cancelled, right? This is not there here. So now, after substituting y by x, 1 plus root 2 v is y by x, 1 minus root 2 y by x, which is equals to c x to the power of 2 root 2, right? So now cross multiply, what we get here, x plus root 2y, x minus root 2y, in the denominator x get cancelled. Final value is c into x to the power of 2 root 2 is nothing but our required solution, right? It is our required solution of a homogeneous differential equation. So some more example we will see in the next lecture. Till then, take care, stay at home, stay safe. Thank you.